Clessie Cummins didn't even finish high school, but with an 8th grade education and a toolbox full of scrap metal, he built an empire. At age 11, while other kids were playing with toys, Clessie was building a working steam engine in his family's barn. By 22, he helped win the first Indianapolis 500. By 30, he'd founded a company that would become a Fortune 500 giant. And at 79, after nearly dying in a runaway truck, he invented a device that saved countless lives on America's highways. This is the fascinating story of hard-earned breakthroughs, bruising setbacks, and a relentless mind that reshaped how America moves. On December 27, 1888, in Henry County, Indiana, the Cummins family farm was buried under one of the worst winter storms in decades. But inside their modest farmhouse, something extraordinary had just happened. Clessie Lyle Cummins entered a world of horse-drawn plows and kerosene lamps, but he would leave it filled with diesel engines and mechanical marvels. By age 11, Clessie had already outgrown childhood. While his classmates struggled with multiplication tables, he was constructing a fully functional steam engine from scrap iron he'd collected around the farm. This wasn't some crude toy. The engine actually worked, complete with a proper firebox, boiler, and connecting rods. Neighbors would travel miles to watch this skinny farm kid fire up his contraption. Steam would billow from pipes he'd soldered with meticulous precision, and the little engine would chug away with the steady rhythm of professional machinery. But Clessie wasn't satisfied with just building engines. He wanted to understand how to make them better. At 12, he repurposed a sewing machine into a small lathe, teaching himself machining techniques beyond his years. The conversion required him to completely redesign the machine's drive system and create new tooling from whatever metal he could find. His experiments weren't always successful, and they weren't always safe. On July 4th, 1900, 12-year-old Clessie decided to celebrate Independence Day by building a cannon. He packed it with far too much gunpowder and fired it near the local schoolhouse. The explosion was so violent it blew the school doors clean off their hinges and shattered nearby windows. His mother was less than thrilled, especially after another of his inventions, a makeshift boiler heated on her kitchen stove, exploded and scalded her with hot water and steam. But even these disasters couldn't dampen Clessie's mechanical curiosity. Word of the boy's unusual talent spread throughout Henry County. Local farmers began calling on him to repair equipment that other mechanics had given up on. By his late teens, Clessie was earning more money fixing machinery than most adults made farming. His reputation for solving impossible mechanical problems was growing, but his formal education ended after 8th grade. In 1910, everything changed when Clessie landed a position as chauffeur and mechanic for William G. Irwin, one of Columbus, Indiana's most successful bankers. Irwin owned a chain of grocery stores, several other businesses, and a collection of temperamental early automobiles that required constant attention. What Irwin got was far more than a driver. During their business trips, Clessie would sit quietly in the front seat, absorbing conversations about finance, strategy, and entrepreneurship. Irwin quickly recognized that his young employee possessed an extraordinary mechanical mind and began treating him more like a business partner than a chauffeur. Then came May 30th, 1911, and the first Indianapolis 500. The Indianapolis Motor Speedway had just been completed, and this inaugural race promised to be the most significant automotive event in American history. Ray Harone, driving a Marmon Wasp, had heard about Clessie, who was a Marmon test inspector, and asked him to join his pit crew. The race was a mechanical nightmare. Early automobiles were notoriously unreliable, and the 500-mile distance pushed every component to its breaking point. Harone's Wasp developed multiple problems that should have ended his chances: overheating, fuel system issues, and suspension problems that would have sidelined most competitors. But Clessie's quick thinking and improvised repairs kept the car running. While other teams struggled with lengthy pit stops and mechanical failures, Clessie had Harone back on track in record time. His suggestions for improving the car's performance proved crucial, and the Marmon Wasp won that historic first Indianapolis 500, averaging 74.6 miles per hour over the grueling 500-mile distance. That victory established Clessie's reputation in racing circles, but his ambitions extended far beyond the track. He'd become fascinated by the revolutionary work of Rudolf Diesel, a German engineer who'd invented a completely new type of internal combustion engine that ran on heavy oil instead of gasoline. Diesel engines offered tremendous advantages over gasoline engines. They were more fuel efficient, more durable, and could run on cheaper fuel. But they were also heavier, noisier, harder to start, and largely untested in American applications. Most American engineers dismissed diesel technology as impractical European nonsense, but Clessie saw opportunity where others saw obstacles. In 1919, backed by William Irwin, Clessie founded Cummins Engine Company to adapt and license R.M. Veed Company's oil engine technology for marine and industrial markets. The early years were grueling. Engines suffered from reliability and starting problems, especially for marine customers, and financial losses mounted. Industrial customers complained of excessive noise, difficulty starting, and frequent breakdowns. The company burned through Irwin's investment at an alarming rate. By 1929, after 10 years of losses, they were weeks away from bankruptcy. Industry experts mocked Clessie's obsession with diesel technology. Gasoline engines were improving rapidly. Electric motors dominated industrial use, and diesel was seen as a dead-end technology that caused more problems than it solved. But Clessie refused to surrender. If he couldn't convince skeptics with engineering arguments, he'd prove diesel's potential with publicity stunts that would grab headlines and change public perception. In January 1930, with his company facing imminent closure, Clessie made a desperate gamble. He installed a four-cylinder Cummins Model U diesel in a used 1925 Packard limousine, announcing that he would drive from Indianapolis to New York City to attend the National Automobile Show. The 792-mile journey would be documented meticulously, with every gallon of fuel consumption recorded and verified. The timing couldn't have been worse. January 1930 brought some of the most brutal winter weather in decades. Roads were sheets of ice, snowdrifts blocked major routes, and detours added hundreds of miles to the journey. The Packard's engine, never designed for automotive use, struggled in the frigid temperatures. But Clessie pressed on, nursing the engine through mechanical problems and impossible conditions. He drove through blizzards, navigated around road closures, and kept detailed logs of fuel consumption while fighting to keep the heavy diesel engine running in sub-zero weather. When he finally arrived at the automobile show in New York, the results were staggering. He'd completed the entire 792-mile journey on $1.38 worth of diesel fuel, a fuel economy figure that seemed impossible to automotive journalists who'd been covering gasoline engines for decades. The automotive press went wild. Here was undeniable proof that these engines could deliver extraordinary fuel economy, even under the worst possible conditions. Orders began trickling in from trucking companies interested in long-haul applications where fuel costs mattered more than initial purchase price. But Clessie wasn't finished with his publicity campaign. In 1931, he entered a diesel-powered race car in the Indianapolis 500. The Cummins Diesel Special, driven by Dave Evans, was built on a Duesenberg Model A chassis and powered by a four-cylinder Cummins diesel engine. It was the first diesel car ever to compete in America's most prestigious race. Racing purists were skeptical. The engines were too heavy, slow revving, and completely unsuited to high-performance applications. The race itself shattered every preconception about diesel technology. While gasoline-powered competitors made multiple pit stops for fuel and repairs, the Cummins Diesel Special ran the entire 500 miles without a single fuel stop. It finished 12th overall, but more importantly, it proved that diesel engines could operate reliably under the most demanding conditions imaginable. Clessie followed this triumph with even more audacious demonstrations. In 1932, a modified diesel car ran over 13,000 miles around the Indianapolis Motor Speedway over 2 weeks, with the engine running nonstop, day and night. The engine never missed a beat, but the physical toll on Clessie was severe. He later admitted the endurance run permanently damaged his health. During one memorable demonstration on the Ohio River, Clessie's test boat ran out of fuel miles from shore with newspaper reporters watching. Rather than admit defeat, he began adding river water to the fuel tank. When reporters asked what he was doing, Clessie explained that he needed to raise the remaining diesel fuel to where the engine's pickup tube could reach it. The fuel floated on top of the heavier water. The reporters, misunderstanding the technical explanation, reported that Clessie Cummins had made his engine run on river water. The story spread nationwide, adding to his growing reputation as a mechanical wizard who could make engines do impossible things. In 1935, Clessie took his experiments to Daytona Beach, where he set a flying mile diesel speed record of 100.755 miles per hour, proving diesel's potential in speed competitions. These publicity stunts weren't just showmanship. They were strategic marketing that gradually changed public perception of diesel technology. Trucking companies began experimenting with the engines for long-haul routes. The U.S. military, impressed by diesel's reliability and fuel efficiency, began specifying them for ships, generators, and other critical applications. By 1937, after key publicity and racing successes, Cummins Engine Company was finally profitable. But success came at a terrible personal cost. Clessie's health, damaged by years of overwork and dangerous experiments, began to fail. In 1938, he suffered what would today be recognized as a severe nervous breakdown and was forced to step back from day-to-day operations. He moved to California, where he set up an elaborate machine shop in his basement and tried to recover his health. Many industry observers assumed his career was over. They were spectacularly wrong. The California years weren't retirement. They were a period of intense personal innovation. In his Sausalito home, Clessie constructed a sophisticated machine shop that filled 2 garage stalls with precision equipment. He hired a skilled machinist and began working on projects that had fascinated him for decades. One of these was a 37-foot sailboat called the Big Dipper, which he spent 4 years building despite being miles from navigable water. The boat featured advanced construction techniques and custom hardware that Clessie machined himself. When completed in 1944, the entire vessel had to be trucked to Madison, Indiana, then sailed down the Mississippi River to Florida. But the project that would define his later years stemmed from a terrifying experience during his 1930 coast-to-coast publicity run. While descending California's treacherous Cajon Pass in a diesel truck, his brakes had failed completely. The vehicle picked up speed uncontrollably, and Clessie nearly died as the runaway truck hurtled toward disaster. That experience haunted him for decades. Traditional friction brakes would overheat and fade on long mountain descents, leaving drivers helpless as their vehicles gained speed. Thousands of truckers face this same deadly situation every year on America's mountain highways. In his late 60s, Clessie began exploring innovative ways to use the engine to aid braking, laying the groundwork for a breakthrough in vehicle safety. His concept was mechanically elegant. By opening the exhaust valves at the top of the compression stroke, he could turn the engine into an air compressor that would slow the vehicle without generating the heat that destroyed conventional brakes. Working in his Sausalito garage, Clessie modified a GMC Suburban with a Cummins diesel engine to test his compression release brake. He lengthened the vehicle's front end by 12 inches to accommodate the engine and fabricated custom controls for the braking system. The prototype was crude but devastatingly effective. When Clessie engaged the brake system on Sausalito's steep hills, the engine's compression would slow the vehicle so dramatically that passengers thought the engine was destroying itself. The system created a distinctive, loud, chattering sound as the exhaust valves opened and closed rapidly. But Clessie knew he'd solved one of trucking's most critical safety problems. He spent 7 years refining the system, working closely with his son Lyle, who had earned a mechanical engineering degree. Together, they developed a practical compression release brake that could be retrofitted to existing diesel engines. The development process involved countless hours of testing on Clessie's 96-foot yacht, where the front 4 cylinders simulated a truck going downhill while the rear 2 cylinders acted as the retarder. In 1959, Clessie sold the patent rights to Jacobs Manufacturing Company, a small Connecticut firm that specialized in drill chucks but was looking to diversify into new markets. The Jake brake, as truckers nicknamed it, revolutionized highway safety virtually overnight. Drivers could now descend long mountain grades without overheating their brakes, preventing countless accidents that had plagued the trucking industry for decades. The Jake brake's distinctive sound, a rapid-fire chattering that could be heard for miles, became synonymous with heavy-duty trucking. Many communities posted "No Jake brake" signs due to noise, though the device became ubiquitous for safe mountain descents. Even in his 70s, Clessie's mechanical curiosity remained insatiable. His final project was a revolutionary engine design featuring rotating barrel cylinders instead of traditional pistons moving up and down. The concept was a bold experiment that he believed could offer smoother operation and more balanced performance than traditional engines. He hired a talented designer and began machining components himself, working with the same meticulous attention to detail that had characterized his entire career. The engine used natural gas piped from his home's heating system, with exhaust routed through a downspout from the garage roof. In December 1967, at age 79, Clessie successfully started his barrel cylinder engine for the first time. It ran smoothly and quietly, proving that his mechanical intuition remained as sharp as ever. The engine represented a lifetime of accumulated knowledge about internal combustion, distilled into one final innovative design. 6 months later, following his wife's death from cancer, Clessie Cummins died peacefully in his California home. He left behind 33 U.S. patents, a Fortune 500 company, and mechanical innovations that had fundamentally transformed American transportation.